Now what I've done is I've built a network in Packet Tracer. Rather than actually build this while we're in the session, I decided to build it first just to save a bit of time, because you guys, you all know how to wire these things up, and you know how to set up router on a stick and things like that, and so it would be a bit pointless really just going over those things again. But I'll very quickly show you what I've done. There's no NAT on here at all at the minute. We'll just concentrate on the NAT configuration. So we've got two routers. The left hand router is running router on a stick. So we've got 4 sub interfaces. Gigabit Ethernet 01, .10, .20, .30 and .40. We've got a switch with 4 VLANs on. VLANs 10, 20, 30, 40. We've got a trunk link. We've got PCs in 4 subnets, 1 for each VLAN. 10.0.0.10, 10.0.10.0, 10.0.20.0, 10.0.30.0 and 10.0.40.0. Okay. We have the inside of the network and we have the outside of the network. What I will do is I'll define those, what's the inside and what's the outside. So let's have a little look. Okay, hit the OK key. So there's the inside. It's a rather lovely pink. And there's the outside. Okay. So Ipnet inside, Ipnet outside. We've got OSPF in between the two routers. And what we'll do is we'll see if we can configure all 4 different types of NAT. So this 10.0.10.0 will use static NAT. The 20.0 will use dynamic NAT to a pool. The 30.0 will use dynamic NAT to a pool with overload. And the 40.0 will use dynamic NAT to an interface with overload. So these bottom 2 will use port address translation. The top 2 will use NAT. Top one being static NAT, the second one down using dynamic NAT. We'll see if we can get all of them to work at the same time. Okay. Actually, I don't know. Just want to get rid of. Yeah. So yeah, we'll see if we can do different versions of NAT all on the same network. That was the idea. Fingers crossed it will work. I'll give you a quick rundown of what we've done on the devices at the moment. So if I do a show run, you can see all we've got is I've created DHCP pools for all of the networks. I probably shouldn't have done that for the one with the static NAT, because this really requires a static IP address, but we can get around that in a moment. So we've got DHCP pools for VLANs 10, 20, 30, 40. I'll put a loopback interface on here. Probably don't need one on here, but I've put it on there really for OSPF more than anything. So if you remember, when we looked at OSPF, there were different ways of doing it. And one of the ways we could do it, create a router ID, was to manually hard code the router ID with the router ID command. Well, I showed you that before, so what I thought I'd do instead is I'd just create a loopback interface, and it would use the loopback interface as the router ID, because it will prefer that to a physical interface. You'll notice we've got router on a stick set up, standard procedure for router on a stick, sub interfaces, encapsulation.1q, identifying the VLAN tag number, IP address being the default gateway. And this is quite nice. Just a bit of fun. You would only really do this in a lab, but notice how I set up OSPF. So what's the result of using that wildcard mask, guys, for OSPF? What does that achieve? Zero 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 255 255 255 255. Go on, Cheng. I bet you want to answer this one. It's everything. Yeah. Yeah, well done, Ryan. Yeah, so basically, by putting that in, this is why you'd only ever use it in a lab. It's basically saying any interface on the router, anything with an IP address on, basically, put it into OSPF. So all of these sub interfaces here, 10010s, 10020, 10030, 10040, the whole damn lot have just suddenly been dumped into OSPF. Okay, yeah. Right, so if we go into the other router and we do a show IP route OSPF, you see the whole lot's coming across. Okay, you wouldn't do that in a production environment, obviously, because if somebody adds another interface to this router, it'll automatically go into OSPF and be forwarding in updates across your network, which is possibly not what you want to do. On R2, we also have a loopback interface, 2222. So show IP interface brief, include up, 2222 there, and we should be able to hit that from these PCs. So let's have a little look. Okay, and the way I did this was I'm going to telnet into that router. Oh, actually, let me just show you the Telnet configuration. So on R2 there, in case you want to emulate this, there's not really much of a configuration, but what I have done is I've created 4 users, one for each subnet, with the username 10, password 10, username 20, password 20, and so on. There's my loopback. There's my OSPF again, and all I've done is I've literally turned around on the VTY lines and put login local, so it goes back to my local username and password database up here, and transport input telnet, nothing more. So what I can do now is I should be able to go into the system at 10.0.10.0. And first of all, I'll just quickly ping 2.2.2.2, and it's happy. Yep. And then what we'll do is we'll telnet into 2.2.2.2, and I'll go in with the user 10 with the password of 10. Okay, you'll see I'm in R2, and I can type show users. And it's showing that I am connected. I'm connected on VTY line 0. I'm the user 10. And I've come in from 10.0, 10.1. Okay, and this is the crafty plan, because hopefully, fingers crossed, once we configure NAT, that IP address will change. At the moment, we have no NAT configured, so it's showing the real physical IP address of the device that I've come in from. In other words, it's showing the inside local IP address. Okay. Likewise, if I go in from the next system, you can see I've been testing this. I've been a good boy. I've been trying to test things. Going with user 20 with a password of 20. Okay. Show users. You can now see that I've come in from 10.0.20.1. Okay. No NAT configured at the minute. So I'm just going to log out. We'll clear the screen. We'll do the same thing up here. We'll just log out. And we'll start configuring NAT. And we'll just see what basically happens. I think we said on the first one we'd configure static NAT. Okay. So let's think what we need to do. We need to configure static NAT mapping from 10.0, 10.1. Now, admittedly, what I've done is I've actually got this coming in using DHCP, which was thinking about it, probably not a good idea if we're using a static NAT mapping. Okay, I'm using DHCP, so that could potentially change. So what I really ought to do is go into my edge router and possibly make a DHCP excluded address. So conft IP DHCP excluded address. We'll make it 10.0, 10, 100. And then what we'll do is we'll go into this machine. Rather than using DHCP to get our IP address, we'll set it to that address. 10.0, 10, 100. Two 255, 10.0, 10, 254, and not that we've actually got DNS up and running at the moment, but I just put it in anyway because I generally do, just to be thorough. Right, let's just check that out now. That's better. So we now have a static IP address on the actual device, so that shouldn't change. Yeah, we can still get through here. Okay. Interestingly enough, if we now telnet into 2222, we're going with user 10 with a password 10. Whoops, didn't hit the enter key. User 10, password 10. We type show users, which is a nice little command. There we go. So we can see the real address we've come in from, because there's no NAT running. Now we'll configure static NAT. Okay. So first things first, we'll identify inside and outside interfaces. Now, this is where it gets interesting, guys. You might think that you can just specify the physical interface. However, if you're doing router on a stick, you need to specify the correct sub-interface. Okay, so Ipnet, sorry, my fault. Let's go into the interface first. Interface, gigabit, Ethernet, Oh, Kev, your head is just not really with it. I can't remember whether it was 00 or 01. Do show IP interface brief. It's 01. Okay. So interface gigabit Ethernet 01.10. Ipnet inside. Cool, that works. Now, so this is a interface for the 10.0.10.0 subnet. And we just made that the Ipnet inside. The serial interface going off to the right to R2 is serial 000. We'll make that the Ipnet outside. Okay, that's good. And even at this stage, let's just try something. Show Ipnet translations. Okay, nothing showing up at the minute. That won't show us anything until we've actually tied the commands together with the long command, which I'm going to do next. So Ipnet. Kev. Conf T. Right. Ipnet. You'll notice that we've got inside or outside. Well, we're on the inside of the network, so we'll go inside static. Inside source, sorry. Static. Followed by the inside local IP address. This is really good because the question mark tells you what you need to put. As long as you know what the inside local address is, in other words, it's the inside host address as it's seen locally from the inside, which would be 10.0.10.100. Yeah, you're good to go. And then it should now say the inside global. There we go. Which is what we want it to be seen as from the outside. Now I'm just going to pick an address somewhere in that subnet that's not in use. So we've got 88.44.22.0 on a /24. What is in use actually? We've got .1 I think on one end of this. Let's have a quick look just to make sure I don't do anything silly. Yeah, we've got .1 on one end of this cable. We've got .2 I presume on the other end of the cable. Yeah, okay. So what we'll do is we'll use something that's pretty easy to see. Let's say .200. Okay, Ipnet inside source static, inside local to inside global. So now that PC at the top there will show up on the outside as 88.44.22.200. Show Ipnet translations. There we go. This is good. Show Ipnet statistics. Okay, we can see outside interface is 000, inside interface is gigabit 01.10. And let's just see if it works now. Okay, previously it was showing up as coming from 10.0.10.100. Now if it does work Fingers crossed. Oh, I should really log out, shouldn't I? Connection reset by remote host. That may actually be the fact that we set Nat up. So let's ping. Okay, we can still ping it. Well, hey, cool. There's still connectivity. Yeah. Let's try doing a telnet to it. Yep. We're going with 10 as the username. 10 as the password. We're in. We'll run show users. Oh man, look at this. Look at this. Yeah. 88, 44, 22, 100. How cool is that? Okay, it's still got the other session in there. That's purely because this is not cleared it yet. Okay, it will take a little while for that to clear. I can't remember how long it takes to clear, but if you look, you've got the little asterisk by the front here. And the little asterisk means this is the active session. Yeah. Okay. So we've gone in and we can see that we've come from a translated address. We're no longer coming from the inside local address, we're now coming from the inside global address. Excellent. And likewise, if we were on the outside and we actually connected to that address, it would take us to this machine on the inside. Okay? Because this machine on the inside is no longer seen as 10, 0, 10, 100. It's now seen as 88, 44, 22, 200. So effectively, this internal machine now has an outside presence via that inside global address. Okay, cool. So there's a static NAT configured. That's nice. Let's log out of that. Okay. What do we want to configure next? Dynamic NAT. Let's see if we can configure a dynamic NAT. This is a little bit more involved. So we'll use the next PC down and we'll create a Nat Pool. Now for this to work, it requires us to create an access control list to identify our internal machines which are allowed to be translated, and also a Nat Pool to define our inside global address range. So we're going to have a think about this one now. And before we forget, we better define the interfaces as well. Now one of the interfaces is already defined because the outside global is the same. Ipnet outside is the same. It's the same serial interface. But we better remember to define the Ipnet inside, which is now on gigabit 01.20. Okay, I don't need to define the Ipnet outside because I've already done that on the other step. It's the same serial interface. Right, so let's have a little think about this. Access control list. Standard access control list. What's the range of numbers for an standard access control list, guys? 1 to 99. Okay. Now I've made you remember that. I'm not going to use a numbered one. I'm going to use a named one. Aren't I cruel? So IP access list standard. We'll call this DYN dynamic ACL 1. Dynamic ACL underscore 1. That looks better, doesn't it? Right. Yeah. Permit 10.0.20.0. Okay, that's a /24, guys. What's the wildcard mask I want for that one? Close. Yep, well done, Dan. 0000255. Okay, and because it's a standard access control list, that's it. In fact, hold on a minute. Let's just check something. Notice we've only got address to match, any, and host. There is nothing else there. There's no protocols, there's no port numbers, there's no destination. It's just the source IP address. So 10.0.20.0 followed by the wildcard mask 0000255. Superb. Okay, so that's permitting anybody on that second subnet down. We'll exit that. We'll create an Ipnet pool. Now I always forget how to do these, but use your question mark. It's not so bad. So there's a name. I'm just going to call it Nat _pool _1. Yeah, it's not very imaginative, I know, but start address range. Okay, so it needs to be in a start address range that's in that global range on the outside there. So I've got 88.44.22.0. What did I use for the static net mapping? I think I used 100, didn't I? If I remember correctly. That's a bloody good question, Kev. Did you use 100? No, 200. There we go. Oh, well, that's all right then. So what I'll do is I will use 88, 44, 22, 64, and we'll end it at 88, 44, 22. Let's see, what's that? 64. What's 32 on there? 64, 32, 96. Then that would be, wouldn't it? Yeah, I think that's right. With a net mask of right from 64 to 96. 64 is a valid subnet number for a network. 64 to 96 is 32, so that would be a network mask of 255, 255, 255, 224. Start address and end address and different subnets. Hang on a minute, what have I done then? Okay, have I done something really stupid here? Oh, yes, I have done something stupid. Should be 95, yeah. I've gone to the next subnet up. Rookie mistake. Well spotted, Cenk. Well spotted. Okay, so that's good. We've got a net pool. We defined our inside. We defined our outside. We defined our access control list. We defined a Nat Pool. All we need to do now is the command that ties the whole lot together. So that will be Ipnet inside source. Okay, now it's not static this time, it's a list. So if we look at the choices, there is only static if you're doing a static map, or there's list. And if we type list, it'll expect the access control list number or name. Okay, now our access control list name is, I'm actually going to copy and paste it so as I can't be wrong here. ACL1. Ipnet inside source list. So translate the IP addresses in the access list DINE ACL1 to the addresses in the Nat Pool. So pool, and then it's the name of the Nat Pool. So what is our Nat Pool's name? Nat Pool 1. So from the perspective of those strange names that Cisco use for these things, it's basically saying Ipnet, go from the inside to the outside. The source for the translation is the inside local addresses in access list DynACL1 to be translated to the inside global addresses in Nat Pool 1. And because there's 32 usable addresses in that Nat Pool, it will allow us to do 32 translations, and then we'll run out of addresses in the Nat Pool. And if we wish to translate any more internal hosts, they'll just have to wait until an address is released from the Nat Pool. Okay, is there anything else we can type in here? Overload. Yeah, we don't want to do that at the minute though. That'll be for a little bit later on. That'll switch on port address translation for a pool of addresses. So we won't do that for the minute. Here we go. Bang. Now, let's see what we've got. Show Ipnet translations. Okay. So currently, we have a translation here from 10.0.10.100. That's this guy up the top here, the very top left PC, on a high port number just used for tracking the connection, to 88.44.22.200. Okay, that's the global address, so that's the address that this top PC gets globally, so that's how it's seen from the outside world. And we're going to 2222, which is the router on the right hand side, on port 23. What's port 23, guys? Telnet. It all makes sense. It all makes sense. So going from this PC up here, we're translating from 10.0.10.100 to 88.44.22.200, which was their static NAT entry, on port 23, because we're going into Telnet on the router. Right, let's see what happens when we go through this one then. So first of all, we'll do a quick ping to make sure we can hit it. Yep, no problems there. Then we'll Telnet. Okay, 20. 20. We're in. Show users. Oh, I should have made that a little bit wider, shouldn't I? It doesn't look very nice and clean like that. That's better. Notice the other ones have timed out now. And we can see that we've gone in on VTY line 0 because that one's freed up again now because the other ones have timed out. This is the active line because it has the little asterisk on it. And we've come in from 88.44.22.65. Whoa! How cool is that? How cool is that? In fact, while we're here, why not? Let's put another PC on that same VLAN, and that should get the next address. So, because it's easy to do, we'll just drop another PC onto that VLAN, and that should get the next address. We've got DHCP set up, so it's dead easy to do. All I do need to do is I need to go in the switch and put the port, whatever port I drop this into. Let's drop it into 10. I need to put that into VLAN 20. Okay, let's see if this will get an IP address on the 20 network. Probably get 20.2, I imagine. Oh, you dopey bugger. Yeah. I'll put it in VLAN 10. 10, 0, 10, 1. Okay. Right. Change that. Oh, dear me. See, this is the great thing with VLANs. This is why we use VLANs. You can remotely access this switch now without having to get out of your chair and put your sandwich and your can of Coke away. You can move PCs from subnet to subnet just by changing the VLAN they're in. So we'll go into interface fast Ethernet 010 and we'll just tell it to go into VLAN 20. There we go. Job done. Right, I'll refresh that address and with any luck it will get an address on the 20 network now. I've confused it. 169.254. Okay, let's give it a few seconds. Back. Hold on, shouldn't be. No, it's only VLAN 20. Yeah, you shouldn't really be able to put, if you make it switchport mode access. By making it switchport mode access, it should only be allowed to go in one data VLAN and optionally one voice VLAN. But yeah, no, it's in the correct VLAN now. So don't know why that's not getting an IP address at the minute. It should do. Show IP DHCP binding. Oh, we've got no DHCP bindings. That doesn't make any sense. Oh, you dopey bugger. I'm typing show IP DHCP binding on the switch. I tell you what, some days. Show IP DHCP binding. Right, that's better. I've got 20.2 now. It's 20.2. It must be this guy here then. He's 20.1. Okay, so has this guy finally got an IP address? He has! Yay! He's got an IP address at last. Okay, so it took a little while, didn't it? Telnet. I just want to see if he gets the next address in the DHCP pool. Not the DHCP pool, the Nat Pool. We'll go in with the. I wonder whether we can get in with 20 again. Yeah, we can. And it works. Look at that, guys. How about that? $88.44.22.65. 88.44.22.66. How good is that? $88.44.22.65. 20.26. So we've got two different types of NAT running at the moment on the router. Show IP NAT translations. It's getting a bit more interesting. We can see a static NAT entry down here, and we can see a dynamic NAT 65. We can see the very next one, 66. If I pulled another PC off and connected it up onto the switch, we've got 67. And of course, once we use up all of the addresses in the Nat Pool, then Houston, we have a problem, because no more internal machines will be able to be translated until one of those addresses is freed up. So, okay, well, this is actually working better than I thought. Next, what we'll do is we'll do exactly the same as we've just done, but we'll create another Nat Pool, and we'll only have a few addresses in that Nat Pool. In fact, we could even have one address in the Nat Pool. There's nothing stopping you having a single address in a Nat Pool. But what we'll do is we'll overload it. Yeah, why not? We'll have one address in the Nat Pool just to show that it's possible, and then we'll overload it. Right, and that will be for this 10.0.30 network. Okay, so let's get a bit of clean space. I'm going to definitely be having a paracetamol after tonight, I tell you. Interface gigabit 01.30. Ipnet inside. Don't need to worry about the outside, it's already on there. On serial 000. We don't need an access control list, so IP access list. Well, actually, I'll tell you what I'll do. Just to prove it, we'll use the other method. So access list 5. That'll be a standard list because it's between 1 and 99. Access list 5 permit 10.0.30.0 slash. Whoa! I wish I could do that. You can do that on a lot of routers. You can actually do that on Linux routers. You just put /24, but we're not on a Linux router, Kev, so we'll need to do 0.0.0.255. Okay. Yep, that's all good. We'll need to create a Nat Pool next, so we'll do an IP Nat Pool and give it a name. I'm just going to call it 123. It's time's too short. So 123, and what should we do with that Nat Pool? Whoops. So we want to have a start address. I'm just trying to think what addresses we've used now. We've used 200. We've used 64 to 95. Oh, 123. Why not? Okay, so we'll use 88, 44, 22, 123 as their start address, and 88, 44, 22, 123 as their end address. In other words, we have a Nat Pool consisting of one address. Net mask. I'm presuming we probably would need to put in, I must admit I've not actually done this before with one address, but I would imagine we just need a /32 mask on there. It seems to be okay. Right. Okay. That's good. I forgot something. Right, so what I'm going to do, I'm going to hit the up arrow, Control A to go to the start of the line and get rid of that. Okay. Hit the up arrow again. The thing I forgot. Oh no, I haven't. Oh jeez, Kev. Sorry guys, I haven't forgot something. It's the next command what I need to put overload on, not this one. So yeah, there's my IP Nat Pool back in again. This is what happens when you don't have enough Guinness, guys. I'm severely lacking Guinness. So there's my Nat Pool, consisting of one address only, 88, 44, 22, 123. And then we need to tie the whole lot together with Ipnet inside. I'm going from inside to outside. My source for translation is in the list 5. And that's going to be translated to the pool. I think I called the pool 123, didn't I? Yep, 123. And here's the bit I was looking for, overload. Okay. As soon as you type overload, it basically now says port translation is in effect. Okay. Now, let's see what happens. We'll ping 2.2.2.2. Yeah, we're good. We can ping it. We'll telnet. Yep, no problem. We'll go in as the user 30 with a password of 30, and we'll do show users. Oh, that's getting to be a bit messy now. Let's just clear that out. And look at that. 88, 44, 22, 123. What would happen now if I put another PC on that subnet? Let's try to do this properly this time, Kevin. We'll get another PC. We'll plug it into Fast Ethernet 11. Go into a switch. And we'll go into Fast Ethernet 11. Switch port mode access. Switch port access VLAN 30. Switch port no negotiate. Switch off dynamic trunking protocol, just as a little bit of extra security there. Spanning tree port fast. We're good to go. Show VLAN brief. Good. Okay. Bring that PC up. DHCP. Hopefully it will get an address in the 10.0.30 network, which it does. Yep, 10.0.32. Lovely. That's cool. So guys, if all is working well, this should also end up with the inside global address of 88.44.22.123. Okay, and it does. Okay. 66 is timed out. I'm not sure which one 66 was. One of these two. It's either that one or possibly, it looks like it was that one then. Yeah, I'm quite enjoying this. So yeah, we've got 65 and 66. These are coming through from the dynamic Nat Pool, where it's just basically it's pulling the very next address in the Nat Pool. We're using a Nat Pool consisting of one address only here, 88.44.22.123. but we're overloading it. So the really interesting thing should be when we run show Ipnet translations on here. Hey. Okay, so there's a static NAT entry. Okay. We've got 88, 44, 22, 1, 2, 3. Twice. Once for machine 10032 and once for machine 10031. So we've got two internal hosts, both being translated to precisely the same external IP address. Okay. Now that's not the IP address that's on the interface of the router, on the outside interface of the router. We've been crafty here. We've created a Nat Pool of one address only, and we're translating it to that one address. We could create a Nat Pool of dozens of addresses and translate it to those, in which case what it will do is it will use different port numbers until it runs out of the port numbers for that one address, and then it will just flick over to the next address and start going through all of the port numbers, which gives you an absolutely enormous number of possible inside global addresses. So yeah, that's pretty neat. Okay, so there's one more thing to do. We've got one more type of NAT to do. And that's where we use overload, but instead of overloading to a pool of addresses, we actually overload it to the outside interface. And to be fair, this is probably the most common way of doing it. I would say probably amount of times I've configured NAT in the real world, 90% of the time I'll have done it this way round. Okay, so first things first. Just to prove a point, we'll open up the command prompt and we will telnet into 2.2.2.2. This is 40, isn't it? Which I can never spell 40. I keep wanting to put a Y in it for some reason. 40. Show users. Okay. Wow, we're almost running out of VTY lines there. Whoops. Sorry guys, missed the edge of the window. There we go. And you'll notice we're coming in from a real inside local address here. A private IP address. It's not hidden. It's not been translated. There is no NAT configured. So let's fix that. This is the one I like doing. I could do this one with my eyes shut. Interface gigabit 01.40 Ipnet inside. The Ipnet outside is already on serial 000, so we don't need to worry about that. Access list we'll need to create. IP access list standard. I'll just use the named one again. I'll just call this pat. Permit 10.0.40.0 255 255 255. What am I doing? 0.0.0255. Yeah. Okay, so oh, actually, there's a little trick I could show you in a little while before we close this one off. And then what we'll do is we will tie it all together with Ipnet inside source list. It's the access list called pat only instead of going to a pool of addresses, we're now just to go to the interface, and the interface we're going to go to will be wrong. It's the outside interface. Serial 000. In other words, it's the outside interface of our edge router, the one that points into the internet. And we'll follow that off with overload. Okay, and that should be that. So let's log out. Notice the connection was refused by the remote host because it knows that it's no longer a valid connection. We can't connect from that IP address anymore because that IP address is now hidden by NAT. So if we do a Telnet again. Ooh, interesting. That's interesting. Might have to clear something for this to work. No, we can ping it. I bet I know why. We've used up all of our VTY lines. Let's just add a few more. So let's do a show run. Line VTY 0 to 4 login. See if we can actually. You could do this on a real router. I'm not sure whether Packet Tracer is going to like this because sometimes Packet Tracer, you know, you'd end up doing things which confuse Packet Tracer a little bit because the designers of Packet Tracer haven't thought that somebody would be crazy enough to want to do something like this. But line VTY. Let's just add another few. So we'll go from 5 to 10. There's 15 on here, so yeah, we'll go from 5 to 10. Login local. I think that might be what we've done. We might have just run out of VTY logins because I'm logged in from quite a lot of devices here. I think I've exceeded the 5. Okay. In fact, let's have a quick look. Show users. It's not showing anything on there. That's good. Right. Yeah, but there's definitely 1, 2, 3, 4. I thought I saw 5 in use at one point. 1, 2, 3. I don't know. Maybe not. Maybe just needed to wait for something to clear there. Right. So going to the right PC. There we go. Hey, we're back. Okay, so this is 40. That's more like it. Yeah, you can see we are actually using 1, 2, 3, 4, 5 lines now. We've actually gone in on VTY2 now for some reason or other. Probably because the other one's timed out. And you can see that if you look at the one we're on, which is the active one, is the one with the asterisk in front of it. We're going in as the user 40 from subnet 10040, and the address we're coming in from is 88.44.22.1. Where is 88.44.22.1? On that serial interface there. Yep. Look. Okay, so we've simply overloaded it to the IP address that's sitting on the serial interface. And it's that top line there. So the machine 10.0.40.1, this guy down bottom left, has been overloaded to 88.44.22.1. Whoa, how crazy is that? Actually, I will show you something. I'm just going to see if I can just quickly show you something. Hopefully it won't completely break anything here, but just as a matter of interest, I want to see how well Packet Tracer can handle something a bit extreme. So what I'm going to do is I'm going to just look at our NAT configurations. Woo, how many NAT configurations? So we've got Ipnet, inside source list, PAT, interface. Yeah, this last one we've done for the subnet 10.0.40.0. We're using an access list called PAT. Okay, and if we look at that access list, IP access list standard PAT permit 10.0.40.0.0.0.255. What I'm going to do, I'm just going to remove that for a moment. Check this out. I hope this will work. It would work on a real router, because I know I've done this plenty of times on real routers. Just hoping it will work. So we'll remove the access list. Okay. And what we'll do is we'll clear the Ipnet translations, all of them. Show Ipnet translations. Okay. Why is this one still showing up? Actually, there you go, guys. There's a question. Why is that one there still showing up? Static one, exactly. That doesn't get cleared. Okay, only clears the dynamic ones. Now what we'll do is we will ping, yeah, no problem, and we will telnet. Okay. And good old Mr. 40 there. The active one is the one with the asterisk in front of it. Notice he's now coming from 10 network. Yeah, it's coming from the 10 network here as well. It's showing up as the 10 network now. Yeah, because there's no NAT going on. What I'm going to do, I'm going to do something a little bit funny now. Just want to prove a point, really, more than anything. Let's see if you guys can follow this one. This is kind of odd, but I can remember strange situations where I've had to do something slightly like this. I'm going to put another PC on that 40 subnet. So let's just hook it into the switch. I'll pop it into Fast Ethernet 015. Switchport mode access, switchport access, VLAN 40, switchport no negotiate, spanning tree port fast, all good to go. That said, I'm not actually going to use DHCP on here because I want to give this a static IP address. I'm actually, just for time's sake, I should put an excluded address on here. But for time's sakes, no, go on, do it properly, Kevin. Put an excluded address on. IP, DHCP, excluded address, 10.0.40.130. Whoop. 130. 10.0.40.130. Okay. Now, Let's go into this PC and configure it with that address. I want to see what you reckon to this. Check this out. So static 10.0.40 130. Two 255.255.255.0 10.0.40.254. Okay, I think we're good to go. Now, ping 2222. Yeah, we got connectivity. So we've now got two machines on the 10.0.40 subnet. One machine has an IP address of what? .10.0.40.1. The other machine has an IP address of .10.0.40.130. Okay. What I want to do is I only want this top machine 10.0.40.130 to be natted. I don't want the bottom machine to be natted. 10.0.40.1. How do you reckon I'd do that? Any guesses? So on this 10.0.40.0 network, I've got two machines, 10.0.40.1 and 10.0.40.130. I only want 130 to be natted. .1, yeah, it's all to do with the access list. So I've removed the access list now, haven't I? So if I do a show access list, there is no PAT access list anymore. So we'll create a PAT access list. IP access list standard, PAT, permit. What do you reckon I need to write there just to get the top half? Because the machine 130 is in the top half of the subnet. The machine .1 is in the bottom half of the subnet. There's your clue. So how would I create this access control list so as only the machines in the top half of the subnet are in the access list permitted and therefore are netted? What will my access list be? Yeah, it will be the wildcard mask, but can you give me the numbers? Tell me what numbers I need to type in next. Very good, very, very good. Okay, but what network address do I need to type in first? Very, very good indeed. Excellent work. Yeah. So what I'm doing there is I've created an access control list permitting 10.0.40.128 with a wildcard of 0.0.127. And if you work this out, if you add 128 to 127, you get 255. Okay. So this is the top half of the subnet, and this is the half of the subnet that the machine 130 lives in. So this means what it's going to do is it's going to permit this machine here, 130, to be translated, but the machine in the same subnet, which is in the lower half of the subnet, will go through with its same untranslated address. At least that's the plan. That definitely work in the real world, so let's see if it will work in Packet Tracer. Okay, here we go then. Right, so this is the lower one. This is 40.1, so this should go through untranslated. and it does. We've got the private IP address range. Okay, so that wasn't even touched by Nat because the access control list didn't include this address range, so it's not allowed to be translated. Yeah. Let's try the next machine with 130. Now this is covered by the access control list, so this will be permitted to be translated. So look at that. And it was translated. And it was translated using our port address translation overload to the interface command. So it was basically take the inside global address of the address that's on the serial 000 interface. Awesome. Well, guys, that was a session and a half, I think. I think you need to congratulate yourselves, give yourselves a slap on the back, and a couple of paracetamols now for that one. Whoa. I think we'll call that one a day, guys. So we've covered NAT, we've covered the theory of NAT, we've also covered all 4 main types of IPv4 NAT. Static NAT, dynamic NAT with an overload, and dynamic NAT with overloading to an interface. Nice work. I'll see you next week. No worries, guys. Take care. Cheers. Cheng, if you didn't have a question, it wouldn't be the same. Go on, go for it. Yeah, no problem. I've recorded this one, so I'll upload this video to the Dropbox. The only difference between NAT and PAT, the difference is when you tap in the overload command in configuration terms, it literally is that one word. As soon as you type in overload, it turns around and it says, right, I want you to use port address translation, and at that point it will actually make use of the TCP and UDP ports for obviously TCP and UDP to make sure that the return traffic goes to the correct inside local address. Yeah. No problem, my friend, no problem. Take care now. See you next week.